Welcome back. This is episode 2 of the series covering the complete book, Artificial Intelligence, NeuroData, and Society, Law at the Edge of Cognition by Dr. Mark Leiser, available to pre-order from Bloomsbury. In episode 1, we established the foundational argument. AI has moved beyond predicting behavior. It now predicts thought. We introduced the concept of NeuroData, signals generated by the brain and nervous system that enable AI systems to infer what a person is thinking, feeling, or intending, often before that person is consciously aware of it. And we introduced neuroprivacy as the legal response that the book argues the law must develop. Today, in episode 2, we go deeper. The central question of this chapter is deceptively simple. Can a thought be computed? And if it can, who owns the computation? Who owns the output? And what happens when that output leaves the country where the thought was formed? This episode escalates from accessible foundations to advanced legal and technical analysis. Whether you are a student, a practitioner, or a researcher, there is something in this chapter that will challenge how you think about the relationship between mind, machine, and law. Let us begin. Part 1. The Basics. What does it mean for a thought to be computable? To understand Chapter 2, we need to start with a question that sounds philosophical, but is actually deeply practical. What is a thought? And can a machine read it? For most of human history, the answer was assumed to be no. Thoughts were private. They existed inside your skull, inaccessible to anyone but you. The law was built on that assumption. Freedom of thought, protected in international human rights instruments, including Article 18 of the International Covenant on Civil and Political Rights, was treated as an absolute right precisely because no technology could violate it. You could not be punished for thinking something. You could only be held accountable for what you said or did. That assumption is now obsolete. Modern neuroscience and AI, combined, have made it possible to infer the contents of mental states from physiological signals, not perfectly, not always, but with increasing accuracy and in commercially deployed systems right now. This is not science fiction. It is the present. So how does it actually work? Let us walk through it at the most accessible level first. Your brain produces electrical activity constantly. Neurons fire, signals travel, blood flows to areas of increased activity. All of this is measurable from outside the skull. An electroencephalogram, an EEG headset, places electrodes against the scalp and reads the patterns of electrical activity underneath. A functional MRI machine reads blood oxygenation patterns in real time. Eye tracking systems follow where your gaze rests, how long it lingers, how your pupils dilate in response to stimuli. Galvanic skin response sensors detect changes in the electrical conductivity of your skin, which correlate with emotional arousal. None of these sensors is new. What is new is what AI can do with the signals they produce. A modern machine learning model, trained on neurological data, can detect patterns that human analysts cannot see. It can correlate a particular brainwave pattern with a particular emotional state. It can identify from eye movements whether someone is reading with comprehension or confusion. It can infer from skin conductance whether a person is experiencing stress, attraction, or deception. And in the most advanced deployments, it can begin to reconstruct, approximately, what a person is thinking about. Not the exact words, but the semantic category, the emotional valence, the intention. This is what Chapter 2 calls computational inferability. The idea is not that machines can telepathically read minds. The idea is that the gap between physiological signal and mental content is narrowing, and that AI is the engine of that narrowing. Every new model trained on NeuroData reduces that gap a little further. The legal significance is immediate. If a thought, or an approximation of a thought, can be inferred from measurable data, then thoughts are no longer automatically private. They become something that can be captured, stored, analyzed, bought, sold, and used against a person who generated them. And existing law, which was designed around the assumption of mental inaccessibility, has no adequate answer. Part 2. Intermediate level. What exactly is NeuroData, and how does the pipeline work? With that foundation in place, let us move to the intermediate level. Chapter 2 introduces a precise and important concept, the NeuroData pipeline. Understanding this pipeline is essential to understanding why the legal problems are so difficult to solve. NeuroData does not simply appear. It is produced through a sequence of steps, each of which introduces new actors, new risks, and new legal questions. Let us trace that pipeline from beginning to end. Step 1 is acquisition. A sensor, an EEG headset, an eye tracker, a wearable biosensor, a smart earphone, a consumer-grade brain-computer interface, captures raw physiological signals from a human being. At this stage, the data may look like nothing more than electrical noise. It is not yet interpretable, but it is already personal data because it is generated by and uniquely associated with a specific human body. Step 2 is pre-processing. The raw signal is cleaned, filtered, and structured. Artifacts, movements, blinks, interference are removed. The signal is normalized. This step requires significant computational resources and is typically performed by the device manufacturer or a cloud processing service. Already, the data has left the immediate control of the person who generated it. Step 3 is feature extraction. The pre-processed signal is analyzed to identify patterns, frequency bands, event-related potentials, connectivity measures between brain regions. These features are not yet inferences. They are statistical summaries of neural activity. But they are far more interpretable than the raw signal, and they encode information about the person's cognitive state. Step 4 is inference. A trained AI model takes the extracted features and produces a prediction. This prediction might be an emotion label: stressed, focused, distracted. It might be a cognitive assessment: the person is experiencing cognitive decline, or heightened attention, or suppressed arousal. It might be a behavioral prediction: this person is likely to purchase, to lie, to comply, to resist. At this step, the data has crossed a fundamental threshold. It has become information about the inner life of a person. Step 5 is application. The inference is used for some purpose: targeting an advertisement, adjusting an insurance premium, informing a hiring decision, flagging a security risk, personalizing a learning experience, or calibrating a medical treatment. At this stage, the original NeuroData signal, which may no longer exist in any stored form, has already produced real-world consequences for the person who generated it. This pipeline has 3 legally significant features that Chapter 2 emphasizes. First, it is irreversible. Once an inference has been made and acted upon, the underlying neurodata that generated it may be deleted. The harm persists, the evidence does not. This creates profound problems for data subjects seeking to exercise rights under existing frameworks like GDPR, which are predicated on the continued existence of the data as a correctable or erasable object. Second, it is distributed. Different steps of the pipeline are performed by different entities in different jurisdictions. The device manufacturer is in one country, the pre-processing cloud service is in another. The inference model was trained on data from a third. The application layer operates in a fourth. The person whose neurodata flows through this pipeline may have no meaningful awareness of any of these actors, and no legal mechanism to assert rights against all of them simultaneously. Third, it is self-improving. Every time the pipeline processes neurodata, the inference model improves. The cognitive states of millions of individuals are not just being read, they are being used to train models that will read the cognitive states of millions more. The population-level implications of this are extraordinary, and they fall entirely outside the individual consent frameworks that currently govern data protection law. Look closely at your second infographic. It contrasts neurodata with conventional biometric data. A fingerprint identifies who you are. Neurodata infers what you are thinking, feeling, or intending. The legal categories that govern biometrics, focused on identity verification and access control, are structurally inadequate for data that infers cognition. Chapter 2 argues that this inadequacy is not a gap to be filled. It is a category error. The law is using the wrong tool entirely. Part 3, Advanced Analysis, Global Risks, Jurisdictional Failure, and the Loss of Cognitive Containment. We now move to the advanced level. Chapter 2 introduces one of its most important and original concepts, cognitive containment, and it introduces the conditions under which cognitive containment fails. Cognitive containment refers to the capacity of a legal system, or a combination of legal systems, to ensure that cognitive inferences derived from neurodata remain subject to meaningful legal control. It is not a technical concept, it is a governance concept. Containment does not mean that cognitive data cannot move. It means that when it moves, legal protections travel with it. Currently they do not. Here is why. NeuroData generated in the European Union is, in principle, subject to the GDPR as special category data, following the Breyer line of reasoning and the broad interpretation of biometric data. But the inference model trained on that data may be deployed in the United States, South Korea, or the United Arab Emirates, jurisdictions that have no equivalent legal framework. The trained model is not the NeuroData. It is a mathematical abstraction derived from the NeuroData. It contains, encoded in billions of parameters, the cognitive patterns of the individuals whose data trained it. But it is not, legally, personal data in most jurisdictions, and the inferences it generates about new individuals are not, legally, the product of processing the original individual's data. This is what Chapter 2 calls the jurisdictional escape problem. NeuroData enters a processing pipeline under one legal regime. The trained model exits that pipeline into another. The persons whose cognition is encoded in that model have no legal relationship with the entities that deploy it, no rights against the inferences it generates, and no mechanism to trace the lineage from their original neural signals to the downstream predictions made about other people. The global risk visualization in your third infographic captures this precisely. Data flows from acquisition through preprocessing, feature extraction, inference, and application. At each step, the data may cross a jurisdictional boundary. At each step, the residual legal protections diminish. By the time the inference is applied, the cognitive containment established at the point of acquisition is effectively lost. Chapter 2 identifies 3 specific global risk scenarios that illustrate what loss of cognitive containment looks like in practice. The first is the authoritarian deployment scenario. A consumer neurotechnology company incorporated in a democratic jurisdiction collects neurodata under that jurisdiction's consent framework. It trains an inference model. It licenses the model to a government in an authoritarian state. That government uses the model to identify political dissidents, religious minorities, or individuals whose cognitive responses to state messaging indicate non-compliance. The data subjects in the democratic jurisdiction had no idea their neural signals would contribute to a system used for political oppression. They consented to a wellness app. They received no notice that their cognitive patterns would be encoded into a tool of state surveillance. The second is the insurance and employment scenario. An insurer or employer operating in a jurisdiction without strong data protection law procures access to an inference model trained on NeuroData. It uses that model to screen applicants. Those whose neural profiles suggest higher risk of stress-related illness, of dishonesty, of poor decision-making under pressure are declined coverage or employment. None of these individuals ever consented to cognitive screening. Many do not know it has occurred. The discrimination is invisible, algorithmically laundered, and legally unassailable under existing frameworks because the inference model is not, technically, processing their personal data. It is applying a statistical pattern derived from other people's data to them. The third is the data colonialism scenario. NeuroData is collected disproportionately from populations in high-income countries with sophisticated neurotechnology infrastructure. Inference models trained on this data are deployed globally, but the populations in lower-income countries whose cognitive patterns, cultural associations, and neurological responses may differ significantly from the training population bear the consequences of inferences that were never calibrated to them. The error rates are higher, the harms are greater, and the legal accountability is non-existent. These are not hypotheticals invented for rhetorical effect. They are extrapolations from documented patterns in the deployment of AI systems more broadly. Chapter 2 argues that NeuroData makes each of these scenarios uniquely dangerous because the data being processed is not behavioral or demographic. It is cognitive. The inference is not about what you have done or who you are. It is about what you are thinking. Part 4, Expert Level, Mental Sovereignty, Cognitive Liberty, and the Architecture of Legal Reform. We arrive now at the most advanced section of Chapter 2. Having established that thoughts can be computed, that the pipeline that computes them is legally ungoverned, and that the global distribution of that pipeline produces harms that no single legal system can contain, the chapter turns to the question of remedy. What would an adequate legal framework actually look like? Chapter 2 introduces two related but distinct concepts, mental sovereignty and cognitive liberty. These are not interchangeable, and the distinction matters for law. Cognitive liberty, as developed in earlier scholarship and extended in this book, refers to the individual right to mental self-determination. It encompasses the right to keep one's mental processes private, the right not to have one's cognitive states altered without consent, and the right to refuse neurological assessment or monitoring. It is a right of the individual against external intrusion. Mental sovereignty is a concept that Chapter 2 introduces to address the inadequacy of individual rights frameworks in the face of systemic population-level cognitive data collection. Sovereignty, in international law, refers to the supreme authority of a state over a territory and its population. Mental sovereignty applies that logic to cognitive data. It asserts that a state has an interest, not merely a regulatory option, but a duty to protect the cognitive integrity of its population against extraction by foreign actors. The distinction is critical. Cognitive liberty gives you the right to say no to having your thoughts read. Mental sovereignty gives the state the right and the obligation to prohibit architectures that read thoughts at scale, regardless of whether individual consent has been obtained. It operates at the level of the system, not the individual transaction. This has radical implications for how we think about international data governance. It suggests that NeuroData should not be treated simply as a species of personal data subject to individual consent and transfer mechanisms. It should be treated as a resource of national and collective significance, analogous to genetic data under the Nagoya Protocol, or to strategic minerals under resource sovereignty doctrine. The extraction and export of cognitive inference capacity should be subject to state-level controls, not merely individual consent. Chapter 2 does not suggest that such a framework exists. It argues that it needs to be built, and it provides a detailed analysis of the doctrinal building blocks that would be needed. The extension of special category protection under GDPR to cover inferences as well as raw data. The development of international instruments analogous to the Convention on Biological Diversity for cognitive data, the imposition of algorithmic transparency obligations on inference models trained on NeuroData, and the creation of cognitive impact assessment requirements for neurotechnology products before they are deployed at scale. Look at your fourth infographic on mental sovereignty. It maps the relationship between the individual, the state, and the cognitive inference architecture. It visualizes what a protective legal framework would need to control at each level. This is the architecture the chapter proposes, not as a final answer, but as a starting framework, a scaffold on which adequate law can be constructed. Conclusion and series bridge. Chapter 2 ends where the most urgent questions begin. We can now compute thought. We have built a global pipeline that extracts, processes, and applies cognitive inferences at scale. That pipeline crosses jurisdictions, evades existing legal categories, and generates harms that are invisible, irreversible, and distributed. And the legal frameworks we have, data protection law, human rights law, privacy doctrine, were designed for a world in which the mind was the one domain technology could not reach. That world is over. Chapter 2's contribution is to map the failure precisely, to show not just that the law is inadequate, but why, at the level of doctrine, at the level of concept, and at the level of institutional architecture, and to propose, in the concepts of mental sovereignty and cognitive liberty, a vocabulary for the legal reform that must follow. In Episode 3, we move to the law's response, or rather, to its attempted response. We examine how existing instruments have been stretched, reinterpreted, and in some cases deliberately misapplied in an attempt to cover NeuroData. We ask whether any of those attempts succeed, and we begin to develop the positive legal architecture that the book argues must replace them. This is Dr. Mark Leiser's Artificial Intelligence, NeuroData, and Society, Law at the Edge of Cognition, available now from Bloomsbury. The link is in the description. This has been Episode 2. Thank you for watching.